Day 3, we are going to look at how spread out is the data. We've been following Connie and Oscar and their first semester test scores, so you've seen them in a few of the problems that you've been doing in your daily practice and also your notes. So for A, it says the mean for the original data is 84. So if you recall, you've figured this data out before. I think it asked in one of the previous questions. And if you've forgotten, mean is another word for average. So to find the average, all you have to do is add up the numbers and then divide by how many there are. So for both of these sets of data, for Connie's and for Oscar's, the average of their sets are 84. And it says, however, they took a new test and they both scored 70. Find the 5-number summary, the range, the interquartile range, IQR, and fences for the new data. So in this course, we haven't talked about fences yet, so I should cross that out. But we are going to go ahead and practice or review how to find the following: 5-number summary, range, IQR, and so on. And then it says, are there any outliers? Again, we haven't mathematically looked at the way to figure that out. But looking at the data, are there any numbers that don't seem to fit in with the rest of the data? All right, so let's use technology then to figure out the 5-number summary and everything else. So to do that, if you have Desmos downloaded on your phone, or if you want to use it on your Chromebook, I think that's the easiest method. You could also do it by hand, but we'll practice using technology. So desmos.com, we'll pull up that graphing calculator. Again, if you have that app, it should look the same or very similar to this. So we're going to put in our data set into a table. So hit the plus sign, put a table. I'll put Connie's scores first in X1, and so that would be 82, 86, 82, 84, 85, 84, and 85. Okay, and it says they both scored 70. Okay, so there's one more test score. We're going to add in the 70 at the end. We'll say Oscar is list Y2. We'll put in Oscar's scores 72, 94, 76, 96, 90, 76, and 84. And then also he got a 70 in his last test as well. All right, so now I'm going to go ahead and click on my next row, and let's calculate the 5-number summary. Let's do Connie's first. So I'm going to do, and you can either type it in or use the, if I hit the calculator, the functions and the stats button, all the stuff is there too. So like, for example, if we want minimum of list X1, we see it's 70. So I'm going to write these down as I do them. So Connie first. And I'll pop up my screen after I've written all these down. All right, so there's 70. Let's erase this and find what, Q1. All right, so I forgot what the thing is, so I'm going to go to functions, stats, it's quartile. And then remember, if you want the first quartile, you have to put a comma after your list and tell it what quartile. So quartile 1, which I don't want it to be small there. There we go. So here's what it looks like to tell Desmos quartile 1. It's 82. 82. Okay, let's change this to quartile 3, 85. Actually, I want the median. Oh, I'll write that down, but I want the median, so 85. Let's do a new one. Median of list X1 is 84. And then the max, we could easily see it, but I'll just change this, right? Max is 86. Okay, so I have written down Connie's 5-number summary, and we'll do Oscar's as well. All right, so what do I want first? Min. And now Oscar's my list Y1, so I didn't change that. All right, so it looks like his minimum is 70 as well. Let's look at his first quartile. So I got to change this to a Y for Oscar's list. Okay, it looks like 74. Let's do median next. Of Y1 is 80. Let's do the third quartile of Y1. Third quartile, 92. And then last we have the max. So let's just write maximum, or max, okay, 96. Okay, so I'm going to pop this down. So that's how you can use Desmos to find your 5-number summary. And here is my data or the 5-number summary of my data right here. Okay, so there's the first thing, find the 5-number summary, done. Next, find the range and the IQR for each. Okay, so let's do range. All right, so range is maximum minus minimum. So for Connie, 86 minus 17 is 16 for Connie's range. For Oscar, he is 96 minus 70, so what is that, 26? So there's their range. And then we're going to look at the interquartile range, IQR, which is Q3 minus Q1. So for Connie, that would be 85 minus 82 or 3. And for Oscar, 92 minus 74. And that would give us 18. I should have used their colors here. 18. This is 3. Okay, so hopefully you're doing okay so far, finding a 5-number summary, arranging an IQR. Next it says construct a box and whisker plot of each of the set of scores on the same axes. So what that means is we're going to make a number line and we're going to put a box plot. I like to stack them so we can kind of compare them. So here's my box plot. We need at least the min, which is 70, and we have to go up to the maximum, which is 96, so we'll go to 100. 75, 80, 90, 100. Okay, so here's my number line. And I did Connie in blue, and remember we used the 5-number summary. The min and max are dots, so at 70 I'm going to put a dot, do it up here, and at 86 I'm going to do a dot, and then 82, 84, 85 I'm going to draw lines. 82, 84, and 85, so these lines are really close together. All right, so there's Connie's box plot. And then we'll take a look at Oscar's. Again, min and max are dots. So at 70, a dot. At 96, a dot. And then Q1, median, Q3 are all lines. So 74, oops, that's like 76. 74, 80, and 92. And we connect our quartiles. All right, so here are the box and whisker plots for Connie and for Oscar. So we talked about it, and I think this was a question. It says, okay, so they both have the same mean, the same average, but whose scores are more spread out? And now with this new 70, we can see the min's the same, but we can see that, again, Oscar, he has some higher scores, but he also has some lower scores than Connie, and so he is less consistent than Connie. His scores are more spread out. Okay, so it says we have spent the last few days studying the center of a data set as measured by median and mean. So those are called center, like measures of centers, median and mean. It says, but we have seen that one set of data can have the same mean or median, but it can look quite different. So again, Connie and Oscar had the same average, but their numbers weren't exactly the same. They kind of told a different story. So now we're going to take a look at 4 new data sets, and we're going to talk about, okay, what's another way to find the measure of center or describe the data? So it says, consider these 4 sets of data, each of which has a mean, an average of 20. So all of these have an average of 20. It says, based on your own intuition, arrange the 4 sets of data from the set that is least spread out from the mean to the set that is the most spread out from the mean. Explain your reasons or the order for the order that you chose. All right, so which is the least spread out to which is the most spread out. So if you take a look at those, and here answers will vary. So if you're in class, I would ask several students, what did you come up with and why did you do that? So I'm going to leave this blank for now. See what you come up with. So you should write something down here. There's no right or wrong answer yet. We haven't learned about this yet, but we will at the end, and then we'll compare. So write down either A, B, C, D, D, C, A, B. Write down the letters in some order from the least spread out set to the most spread out. And then in class, we're going to take a look at Rinky, Dinky, and Minky, who are 3 students looking for a way to assign a number to measure how spread out the data is. They want a method in which the bigger the number, the more spread out the data is from the average. So the bigger the number, it indicates the data is more spread out. It says Rinky liked the idea of using range. of the data to measure the data spread. For example, you find the range for set D by taking the biggest, the max, minus the smallest, the min, 9, and that is 22. All right, so we did Rinky already, and that was 22. All right, so go ahead right now and take a look at the data, and can you find the range, like Rinky, of sets A, B, and C? All right, so set A, biggest minus smallest, 21 minus 19, would give us the range. And so set A has a number of 2. Set B would be 30 minus 10 for a range of 20. And set C would be 28 minus 12 for a range of 16. Okay, so according to Rinky's method, what the number indicates is that set A is the least spread out, C is the next least spread out, B, and then D. All right, so using Rinky's method of range, here is the order that we get from least spread out to most spread out. So think back to your order, and I would ask you if we were in class, okay, how many of you used Rinky's method? Okay, so now Dinky is another person looking at the same data set, but he or she proposed finding the distance of each number in the list from the average, from the mean, and then just adding those distances together. Okay, so Dinky has a little bit more complex method, and let's take a look at Dinky's method, what he did, and the examples with set C. All right, so he looked at the distance from the average. Remember, for all of these data sets, I should have underlined it, all of these data sets have an average of 20. So keep that in mind. Okay, so we're going to find the distance of each number from 20. So how far is 12 from 20? Well, it's 8 units away from 20. How far is 13 from 20? It's 7. So that's where Dinky got the 7. How far is 27 from 7? That's 7. And he got a bunch of numbers, he or she. And so Dinky added up all these numbers together and got this new number, 44. So according to Dinky's method, set C has this number of 44, which I will circle right here. Okay, so then in class I would have you do the same thing. What is the distance from the mean for each of these data points, and then add them together. So if we're looking at set A, how far is 19 away from 20? It's 1. How far is 20 away from 20? It's 0. How far is 21 away from 20? It's 1. And then we would add those numbers together, and set A has this number, according to Dinky's method, of 4. Then we would take a look at set B. Again, you're looking distance from 20. So how far is 10 away from 20? Well, that's 10. How far is 20 away from 20? Well, that's 0. How far is 30 away from 20? And that's 10. Okay, so if we add up set B's numbers, set B has this number of 40. And then we'll look at set D, again, distance from 20. So how far is 20 away from 9? And that's 11. How far is 20 away from 20? Well, each of those is 0 away. And then how far is 31 away from 20? And again, that is 11. And so set D has this number of 11. So now, according to Dinky, let's put them in order from least spread out to most spread out. And that would be set A, D, B, C. So again, in class, I would say, all right, how many of you are Dinky? How many of you use Dinky's method to find these numbers to organize the data? And so several of you might have A, D, B, C. Okay, we'll look at the last student, Minky. Minky's idea was to ignore the highest and the lowest data items, removing just one item from each end, even if there were ties. And then he said one should find the remaining data item that's furthest from the original mean and use that distance to measure the data spread. So furthest from the original mean. For instance, with set B, Minky would drop the lowest number, one of the 10s, and the highest numbers, one of the 30s, leaving just 10, 20, 20, and 30. Because 20 is the maximum distance from any of those numbers, so you look for the maximum distance from 20, and the distance from 30 because the mean is 20, the maximum distance from any one of those numbers, and the mean is 10. All right, so if we take a look at it, the biggest distance from the average is the number. So 10 would be set B. All right, so let's do that one together. Minky's method. I'm going to erase this right here, and we'll just do it right on the table here. Okay, so Minky's method, drop. and then find the largest distance from the mean. And so either way, the largest distance from the mean is 1, and this is for Minky. Okay, and then we already did B, but again, he dropped it, and the largest distance away from the average from any of the numbers is 10. All right, let's take a look at set C. Drop the numbers. What's the biggest distance from 20? And that would be 7. And then the last one, the biggest distance from 20 is 0. So now Minky's method, 0 is the lowest number for set D. Oh, sorry, I should have put them here. So this is 0, 7, 10, and 1. Okay, so according to Minky's method, the least spread out is D. And then A is the next smallest number, CB. Okay, so again in class, I'd be like, all right, who is Minky? Who has order D, A, C, B? It says, examine your answers, 1 through 3 above. Which method is the closest to the ordering that you chose? And then number 5, can you explain which strategy you would use after looking at the 3 methods? Which one do you like the best? Which one do you feel gives us the best measure of the spread, and why? So I'd give you time in class to come up with, which one do you like best and why, and then we would discuss. Okay, so then with that idea in mind, measures of spread, you would do the day 3 daily practice, which is review. Okay. All right, so in class we do day 3, and the assignment then would be the next, is it 2 pages? Yep, next 2 pages, 13 and 14. Oh, YouTube.